In this video, we are going to look at how to graph a parabola. So, as far as graphing a parabola is concerned, there's 5 steps involved. First thing, we need to find our x-intercepts. Then we need to move on and find our y-intercepts. Then we need to consider our axis of symmetry. Then we need to consider our vertex. And then finally we can round off with a discussion about whether the parabola is concave up or concave down. Let's go through what each of these steps means in turn by considering an example. Let's say, we'll go down here, that we want to graph our parabola y is equal to x squared plus 5x plus 4. Let's start off with finding our x-intercepts. And to find our x-intercepts, what we need to do is make y is equal to 0. And the reason for that is because when we look at our Cartesian plane, okay, our x-intercepts are along our x-axis. But can we see, okay, so remember in terms of y, okay, y, equations for y kind of go horizontally, right? Now, along the x-axis, this is when the equation for y is equal to 0, okay? Y doesn't actually have a value there. So that's why whenever we're finding x-intercepts here and here, we need to make y is equal to 0. So what does that look like? In the equation, rather than having y is equal to x squared plus 5x plus 4, we are going to have 0 is equal to x squared plus 5x plus 4. And then we need to solve for x to find our x-intercepts. So for that, simply comes down to solving a quadratic equation using our factorization method. So here, I need to find two numbers that have a sum of positive 5 and that multiply to give us positive 4. And for that, we can clearly see that our numbers are 4 and 1 because 4 plus 1 is equal to 5 and 4 times 1 is equal to 4. Good. So using those numbers, let's write those straight into brackets. So we'll have x plus 4, close bracket, x plus 1 is equal to 0. And then from there, what we can do is solve each of the expressions in the brackets by equating them to 0. So we'll have x plus 4 is equal to 0, so then x is equal to minus 4. And then we'll also have x plus 1 is equal to 0, so then x is equal to minus 1. And those are our x-intercepts. So therefore we should conclude by saying x-intercepts are negative 1 to 0 and negative 4 to 0. We should always write them as a set of coordinates. Okay, excellent. Those are our x-intercepts. Now what we can do straight away is kind of just put them straight on a Cartesian plane. So let's get that up over here. Okay, y, x. So then we know our origin is here. So then we know that our x-intercepts are going to be minus 4, 0. So put that there. And then minus 1, 0. Put that there. Excellent. So that's our x-intercepts. Now what we need to do is find our y-intercept. And for that, let's continue going along here and consider our y-intercept. Now for our y-intercept, okay, here what we need to do is make x equal to 0 because looking at our Cartesian plane, okay, here's our y-intercept, sorry, y-axis, and then we need to consider the intercepts. Along that y-axis, that's where x is equal to 0. So you have x equal to a random number k here, and then x equal to another random number here. X equals 0 falls on the y-axis. So that's why we set x is equal to 0 to find where our graph intersects that y-axis. So let's just quickly refresh ourselves with our equation. So then we'll have our equation is y is equal to x squared plus 5x is equal to 4. So whenever we see x, we're going to replace that for 0. So instead we'll have y is equal to 0 squared plus 5 times 0 plus 4. And then solving that down, we get y is equal to 4. So therefore, in terms of our coordinate, it is going to be 0 and 4. And then, now that we've got that, we can put that straight on our axes. Good. So we found our x-intercepts and our y-intercepts. The next thing we need to do is find our axis of symmetry. Now, there's two ways we can do this, okay? The easy way is to say, okay, well, let's talk about what an axis of symmetry is first. The the axis of symmetry, so let's just draw a circle or something. The axis of symmetry is the line that cuts down that circle down in half, so that whatever is equal on one side is the same as what's on the other side, okay? So similarly, when we're talking about a parabola, so something looking like this, our axis of symmetry needs to chop the parabola in half. Now, an obvious way to find that is to have a look at where our x-intercepts are and say, okay, well, it makes sense that our axis of symmetry is going to be exactly halfway down, or halfway between where our two intercepts are. So therefore, what follows is that when we're finding the axis of symmetry, all we need to consider is the average of our x-intercepts. So considering that, we have our first x-intercept, so average first x-intercept is -4, next one is -1, and we're going to divide that by 2. When we do that, we'll get -5 on 2, which is the same as -2.5. So we know that therefore our axis of symmetry is going to be at where x is equal to -2.5. So that's the first way we can do it. The other way that we could do it is by considering our equation, and maybe for this I might go on a separate slide. So we have y is equal to x squared plus 5x plus 4. What we can do is use our axis of symmetry equation, x is equal to minus b on 2a. Now, the way we get b and 2a is we actually write our template equation for our quadratic, ax squared plus bx plus c, and we match up each of the terms in our quadratic to a, b, and c here. Okay, we don't need c, so we can ignore that. So with a, we can see that a is going to be equal to 1, and then with b, that b is equal to 5. So therefore, using our axis of symmetry equation, we can say that x is equal to minus b, so minus 5, all over 2 times 1, which is a. And then we can simplify that down to -5 on 2, which is -2.5. So that's our second way we can find our axis of symmetry. Okay, we can do this by using our axis of symmetry equation that we have. So you can use either one, whichever works best for you. Okay, let's go back over here. So we know our axis of symmetry is going to be x is equal to -2.5. The next thing we need to do is to find our vertex. Okay, so let's go over here, our vertex. And the way we find our vertex is that we simply take what our axis of symmetry is and we substitute it into our quadratic equation to find what the corresponding y value is at that point. So we know our axis of symmetry is -2.5. We know our quadratic equation, or parabola we're graphing, is y is equal to x squared plus 5x plus 4. So all we're going to do is substitute 2.5 in for x to find out what y is equal to at that particular point. So let's do exactly that. So here what we'll have is y is equal to -2.5 squared plus, let's rub that out, it's going to be plus 5 and then -2.5 and then plus 4. And once I've put it into a calculator, our answer is going to be -2.25. So therefore, what we can say is that our vertex, okay, is going to be equal to -2.5 and -2.25. Okay, so then we can just put in our vertex there. -2.5 and then -2.25. Okay, awesome. Now you're probably wondering, why do we have our vertex along our axis of symmetry? And the reason for that is because, remember, the vertex, the lowest point or highest point in the parabola, we'll talk more about that in a second. The vertex always falls precisely halfway between our x-intercepts. It falls halfway between the two arms of our parabola. So therefore, it always lies on our axis of symmetry. Okay, excellent. So we've got all our terms. Now the final thing that we could consider is concavity, which in all honesty we've probably already answered through looking at all of our points. So concavity is a fancy way, let's just go down here and explore. Concavity is a fancy way of saying which way is the parabola facing. Is it looking like a smiley face? If so, this is concave up. Or is it looking like a frown face? If so, this is concave down. And the way we determine that is by looking at our x term. Okay, so here we have x squared plus 5x plus 4. Because our x term is positive, okay, there's, we don't write a plus in front of it, but there isn't a minus. Because it's positive, we have a concave up situation. If we had an equation that was negative, then that would be concave down. So here we have a concave up parabola, meaning looks like a smiley face, and our vertex is going to be our lowest point. In contrast, with a concave down parabola, our vertex would be on top and it would be our highest point. So that just helps us know which way we need to draw our parabola. So here, let's draw it in. So we know it's concave up. So we'll start from here, go through our points, always put arrows, and always label the parabola with the equation that we started off with. Okay, so to recap, to graph a parabola, what we do is we start by finding our x and y intercepts. As soon as we've done that, we find our axis of symmetry either by taking the average of the coordinates or by using our axis of symmetry equation. Then we find the vertex, which lies on our axis of symmetry. We find our vertex by taking what our axis of symmetry was and substituting it in for x in our quadratic equation. And then we find the corresponding y coordinate and we plot it down here. And then finally, we can think about concavity in terms of, is the parabola concave up or concave down? And that will help us think about whether we've got all our points correct. So that is how you graph a parabola in 5 steps.